Good morning. Our group Binary Vision would like to present our project Suicide Rate Visualization and Prediction. The members of our group comprise of Teja Alle, Shivani Sharma, Krutin Trivedi, and myself Jay Gajjar. About 800,000 people commit suicide every year according to WHO, which is roughly one person every 40 seconds. Due to the brevity of this matter, we have chosen this topic to get an insight into the reasons and statistics of suicide rates of the countries through the years. We wanted to find the relation between different factors such as GDP and suicide rates and break down the data into smaller chunks to understand how each small aspect, such as gender or age group, is affected by suicide. We have used the Kaggle dataset, which provides us an overview of all the suicide rates through the countries in the world from 1987 to 2016. As you can see in our first tab here, this bar chart shows us the total number of suicides between 1985 to 2016 for all the countries. Now, for the hover data, we have shown the country name along with the total suicide count. And when we click on it, it gives us details into the suicide rate for each country. As you can see, the line graph here shows us the increase and decrease in the suicide rates through the years. When we switch to the gender tab, it shows us the suicide rates, the total suicide rates for the males in the country, as for the females, through all the years from 1985 to 2016. Similarly, when we switch to age, it shows us the percentage of suicides for each age group as listed in this legend over here. When we scroll down further, we can go ahead and predict for the future years. Since, as we saw here, Russia and Japan seem to have high rates of suicides, I'm going to choose one of them. I'm going to choose for 35 to 54 years, and I'm going to choose for male. And let's say the year is 2022. And if we go ahead and predict, we can see that the suicide count for 2022 is 5716, and the model accuracy is 0.99, which is quite high. For prediction, we have used decision trees, random forests, and linear regression. We then compare the results from each of these three and the accuracies of these three and return the one with the highest accuracy. Let's try to predict one for a country that has low suicide rates. So that could be Argentina or Albania. If we go to Albania, choose 15 to 24, let's choose female. And as you can see, the prediction is quite low, it's 6.74, and the efficiency is 0.73. Now, when we go ahead, we have also displayed the visualization by country. So as you can see, we have used a choropleth map and we have used an animation which will show us the suicide number or whichever aspect we choose from this drop down through the years. So this helps us understand the relation between the GDP per capita and the suicide number. For example, if we want to select GDP per capita and see how it has changed through the years, we can see it right here. And similarly, now in relation to this, we can see how the GDP per capita has changed in the United States through the years. As it has decreased a bit, let us see the suicide count. You can see that the suicide count almost remains the same, and it also increases in other areas when the GDP has gone down. Similarly, now we move on next to the visualization by categorical data. In this, we have allowed the user to choose the type of chart that they want, and we are going to choose. We have given them three categorical data types to compare. For example, age, generation, and sex. So first we are going to go ahead with the age and the group bar chart. As you can see right here, let me zoom in. And you can see here that for Argentina, these are the different age groups and these are the total number of suicides for the years. Now, if we press on the animation, we can see how the suicide rates are changing through the years. Similarly, we can compare this with the help of different types of charts, such as a stacked bar chart. And you can see them changing through the years. We can use a scatter plot. In the scatter plot, we have used the size of the scatter plots as the GDP per capita. So the higher the GDP per capita, the greater will be the size of this. And as we go through the years, you can see them changing. And lastly, we have the scatter geoplot, which shows us the plots throughout the countries. Now, since all of them are based on country and not locations within the country, all of them can be shown, all of them are overlapping, and then therefore we can only see one dot. Now, as you can see right here, through the different countries based on their GDP, you can see the Bahamas has a low GDP per capita, and therefore its size is smaller than the USA, which has a higher GDP per capita. If we just want to see a particular age group, we can double click on it, and we can see the data for just that age group. This can also be shown with the help of the visualization through the years, and you can see the slider moving, and we can check out how it changes through the different years. Similarly, we can change this for generation. Zoom in, and as you can see how it varies from different generations, and we can also change it for sex. This shows us the relation between the genders and the suicide rates. Now, the benefit of this is that the user can use the different types of categorical data to understand the relationships between suicides and the category. Along with they have the choice to select whichever graph they want, which gives them a better understanding of this data. Next, we move on to the correlation between the attributes. Here we have a number of charts that give us an insight into different details. For example, this chart gives us information of how the suicide rates have changed throughout the years. This is the total suicide rates across the world in each of these years. You can see that in 2002 and in 2003, they have been the highest, whereas it has been quite low in 2016. Now, as we move down, we can see the suicide numbers and the relation of them with the gender. There you go. All right, so as you can see, the generations and the different, we have used a stack bar chart here, and it shows the group bar chart here, and it shows the different relation between the suicide numbers and the sex for each of the generations. As we move down, similarly, we can see a bar chart that shows us the different relations between the age groups and the sex. Similarly, as we move down, here is a scatter plot that shows us the suicide rates between the GDP for the year and for the number of suicides through the years. As we move down, here is a plot that shows us the different relation between the suicide and the GDP per year. This shows us the correlation between them. As you can see, the GDP moving, changing across the years. This helps us analyze how the GDP affects the total number of suicides across through the years. Lastly, we have a feature correlation plot, which shows us the correlation between the suicide between the different factors and the suicide number. We have also enabled the user to choose which two factors they want to find a correlation between. For example, if a user wants to find the correlation between the total suicide number and the GDP per capita, they can do it right here. As you can see, this shows the correlation. We have used the Pearson correlation efficient for this particular correlation. And there you go. You can see the suicide per 100K and the GDP per capita. We are going to explain the visualization by continent. In this, we have shown the relations between suicides throughout the continents, which gives us a broader perspective compared to the visualization by country. As you can see from this bar chart here, that shows the suicides by the continent for the genders through the different years. This shows the total number of suicides between 1985 and 2016. You can see that Europe has the highest number of suicides, and on an average, we can clearly see that the number of male suicides are quite higher than the female suicides through all the continents. Similarly, if we try to see the suicides per 100K people by the continent, these are the different statistics. Europe still leads the way, as you can see, and males have a higher tendency to suicide as compared to females. Going down further, here we can see the division based on the age groups. You can see that on an average, the 75 plus year people have a higher tendency of suicide as compared to the others. Similarly, we have a chloropleth chart which shows us the scatterplot chart compared to the continent-wide suicide, and here we can see it varying through the different years. As you can see, the Europe has a higher number as compared to Europe and Russia have a higher number compared to the rest of the continents. In the end, we have used a pie chart and a sunburst chart. For example, this sunburst chart shows us the different relationships based on each continent. As you can see, Europe covers more than half of the entire percentage of the entire world, so closely followed by Asia and North America, and the other continents form a very tiny part of the total number of suicides through the different continents. Similarly, this shows a very high level overview continent graph. As we discussed above, we can see that Europe is 50.5 and Africa is the lowest with 0.168 percentage. And that concludes our group presentation. Thank you.